reduce injuries. They're not set up to prevent collisions in the first place. This is because of the lack of incentive from the companies to prevent collisions. If more crashes happen, more cars are being sold, more money is being made by car companies. More crashes means more money for insurance companies, and there's no major incentive for them to prevent collisions in the first place. Now, the other problem that we find is the proliferation of smartphones in today's society. Everybody has a smartphone, and these are causing distractions to drivers right now. We feel that instead of being a part of the problem, that we could use smartphones as part of the solution, and using a network of connected smartphones with their Wi-Fi direct connections and GPS signals to build a network of phones to detect and warn drivers of collisions. However, we found that things are not quite this simple. When we were first setting out to start this project, we were given Wi-Fi Direct on Android phones as a project constraint. And what Wi-Fi Direct is it's a direct peer-to-peer connections between Android phones that can be used to create a network of phones that then could have been used to create a system for avoiding crashes using GPS and heading data. However, what we found was early on in the project that Android's Wi-Fi Direct setup is unstable, confusing, and sometimes difficult to use. We looked for existing libraries that could help us work with Android's Wi-Fi Direct. However, we found that everything that currently exists binds the Wi-Fi service to the UI, which would handcuff us into an existing pattern that didn't fit our needs. Then, instead of using one of these libraries, we worked on some basic initial connections using the standard implementations, but we found that service discovery and connections between phones were inconsistent actions, with some discoveries and connections failing for unknown reasons. Lastly, Wi-Fi Direct connections are inherently slow to establish, and this is a problem with what we intended to do with these connections, working on sending data through a live traffic environment. And these connection speeds really need to improve before the goals that we've set out to accomplish can be accomplished. Now, what we found when looking for many answers online to a lot of our problems is that other developers working in Wi-Fi Direct are experiencing these same challenges that we are, and the general emotion towards the technology is that of some frustration. While searching for answers, we found quite a few quotes and quite a few answers that looked something kind of like this. So what we did to start getting rid of some of this frustration is, as a team and as a sponsor, we decided that we were going to take a shift of plans.
So our original requirements were motivated towards our big picture problem. We wanted to be able to make automatic connections between phones using Wi-Fi Direct. And over these connections, we wanted to be able to send GPS data and then be able to utilize algorithms to analyze that data to detect if there's a potential car crash about to happen. We then wanted to be able to provide a warning to the users of this phone that would give them enough time to somehow react with the potential of avoiding these car accidents altogether. So one thing that we quickly identified was that there was a bit of a technology gap between what we needed Wi-Fi Direct to be able to do for our app and what it could do. So we had a meeting with the sponsor, and the basic question was, which direction do we go? Do we move towards crash avoidance and try to develop GPS algorithms, assuming that we can figure out the Wi-Fi Direct part, or do we focus more on Wi-Fi Direct and see what it's going to take to actually close this gap to be able to solve the big picture problem that we had? And the result of that meeting was a modified set of requirements. So the modified requirements that we came up with were to be able to collect some sort of timing and reliability data on the basic Wi-Fi Direct functions, so that, and then basically collect a whole bunch of data and then be able to store that data to analyze it. And what this would allow us to do is identify some of those pain points and figure out what functions we needed to focus on to close the technology gap. We also wanted to simplify the usage of Wi-Fi Direct. We kind of mentioned this previously in our midterm presentation, but Wi-Fi Direct suffers from the problem that not a lot of people use it because of how difficult and unreliable it is to use. And because of that, Android doesn't have a lot of incentive to fix these problems. So we wanted to try to somehow simplify that to lower that frustration level, encourage more usage of Wi-Fi Direct as a whole, and provide that incentive for a lot of these problems to be fixed. And then finally, we wanted to build some sort of app to be able to demonstrate the Wi-Fi Direct functions that we were implementing. And what this allowed us to do is learn more about the Wi-Fi Direct framework by being able to actually physically execute a lot of these functions and find out what they do. And it was more towards figuring out the pain points and what we needed to correct. So the solution we came up with for these modified requirements were one, to develop a library that simplified that Wi-Fi Direct usage. This abstracted a lot of the complexity of Wi-Fi Direct from the applications that we were going to build. And we also wanted to make that publicly available, again, to encourage other developers to use it. If we could provide a simple interface for people to be able to easily use Wi-Fi Direct, more people would want to actually use it. We also wanted to develop a prototype app to demonstrate the functions of our library. And this really helped because as we put more features into our library, our prototype app would then evolve to execute those functions so that A, we could make sure they were working correctly, and B, it helped us understand them. Sometimes when we were implementing functions, we didn't quite know how they worked until we tried them, and then we're actually able to manually test them. On top of that, we wanted some sort of automated way to run these tests so that we didn't actually have to manually go through all these tests. Because a lot of this is happening on 2 phones, it's difficult to come up with a way to automate this, so we actually felt it necessary to build an app to be able to do this for us. And this allowed us to collect massive amounts of data so that we could more accurately identify these pain points and also be able to put more testing into the reliability of the Wi-Fi Direct functions. And finally, what we did a lot of was documenting a lot of the issues that we had. Anytime we had a question, we put them into a live document. And when we got answers to those questions, we put those in there as well. And we also left the unanswered questions. And this basically summarized a lot of the Wi-Fi Direct information that was out there into one document, so anybody coming into the framework could see all those questions and answers because they were very common and not have to duplicate all that research. It pulled a lot of those sources into one convenient place just to kind of help simplify that initial startup to using Wi-Fi Direct. So here's the architecture of what we were able to develop. In the upper left corner is our Wi-Fi Buddy. That's the library that we implemented that did a lot of the Wi-Fi Direct functionality and simplified it. We actually developed 2 apps that utilize this. The top one is Wi-Fi Direct Tester, which executed the manual test for us and was our prototype app. And then on the right side, you'll see the data collection tester. That's the one that was actually able to automatically run the test and collect a lot of data on the phones for us. We then needed to get this data somewhere where we could analyze it outside of the phone. So we chose a MySQL database to push the data to. And in order to get that data from the phone to the MySQL database, we provided a REST API for the phone to interact with.
So up next we have a demo of some of the apps we actually built. Now obviously we can't demonstrate the Wi-Fi Buddy library directly because it's a library, but what we can do is show some of the apps that we built using that library. And the first app we're going to show serves as a demo of how a developer might use our Wi-Fi Buddy library, and it also serves as a bit of an introduction to Wi-Fi Direct on Android. So the first screen, starting on the left, is the start screen when you open the first app. And it gives you a few simple options like toggling your Wi-Fi on and off. You need Wi-Fi on to use Wi-Fi Direct on an Android phone. And then it also allows you to register a local service. And a local service is a service that's broadcast out for other devices to find and connect to peer-to-peer. If you want to find other services that are being broadcast by other devices, you need to discover them. So tapping Discover Local Services creates a discovery request and takes you to the service discovery screen, where you'll wait until the phone actually uncovers the nearby peer-to-peer services being broadcast by other phones. And once you've uncovered a service, you can attempt to connect to it. When you attempt to connect to another phone, the other phone prompts the user to approve of that connection. And this is an Android prompt, so in the normal connection flow, the user has to interact with it. You can't programmatically get around an Android prompt. Now, Wi-Fi Buddy actually does provide an alternate connection flow that allows the phones to connect without this prompt. But the standard flow, the user always has to interact. So once the phones are connected, the library behind the scenes establishes socket connections between the devices and allows communication to occur. So for the purpose of the demo, we built a simple chat application that allows the 2 phones to directly message each other. And what we're going to show next is what this looks like when the phones are already connected to each other. So the app's going to open, and because the phones are already connected, it jumps straight to the chat screen. And we're going to show some messages going back and forth. And now this can be any sort of data. It can be, because it's sent between the phones as bytes. So you could send anything between them. And to show that, we're actually going to send a picture between the 2 devices. And as you can see, the app continues running even when the camera is brought up, so it does run in the background, which is one of the pain points of Wi-Fi Direct that we mentioned previously. So this is another app that we built. This is the data collection app that Chris mentioned earlier, and we built this to help us run tests against our library and get some real-world metrics about it. So you can select the test that you want to run and choose how many times you want to run it, and then begin executing these tests and set the phone to the side and wait for it to finish. And so this is really nice because we can run through our tests automatically and in numerous times. And as these tests are running, the data is being stored locally on the phone in a SQL-like database. And the reason we do that is because when you're connected via Wi-Fi Direct, you can't actually use a regular Wi-Fi network. So we can't guarantee that you have an internet connection on these test devices while you're running these tests. So we store it locally, and to allow you to view the data as it's coming in, there's a View Database button that allows you to actually view and browse the database on the phone. And when the tests have completed and you're back on a normal Wi-Fi network, you can simply tap Post, which will send the data to our REST service and write it to the MySQL database. This allows us to aggregate our data all in one location, and on completion of the post, we can clear out the phone's local database, saving us memory on our test devices.
So using our Wi-Fi Direct testing and data collection app, we decided to focus on service discovery, and we wanted to try to determine where the issues occur and what factors cause these intermittent issues that we keep experiencing. So we set up some controlled test scenarios where we tried to limit as many variables as we could. So we set up 2 phones about 50 feet apart. One phone would add a local service and the other phone would continuously discover that service. And so in each scenario, we would perform 1,000 test cycles and reboot the discovering phone after every 100 cycles to try to get rid of any degradation that may occur. So in this graph, you can see that we have a blue phone discovering another blue phone with very little network activity nearby. So this would be the ideal scenario where you have 2 of the same phones connecting to each other with little network activity. And you can see that the median time to discover a service is about 0.4 seconds. And that would be reasonable for a crash avoidance app, but as you can see, there's still many spikes throughout the graph, and many of them reach several seconds, so that would be way too long to detect a collision. And after you discover a service, you still have to connect to the service and transfer data. So this test scenario shows the same 2 phones discovering, except in an environment with a lot of network activity. And you can see that the median discovery time raised to about 0.9 seconds, and there are still several spikes throughout the test scenario. And based on these results, we concluded that Wi-Fi network activity does have an effect on service discovery. In this scenario, we're in the same environment with heavy network activity with 2 different phones discovering. You have an LGE Nexus phone discovering a blue phone. And here you can see the median time to discover raised to about 1.7 seconds. And based on these findings, we concluded that the type of phone also has an effect on service discovery. And you can also see in these graphs that even though we're running the same test over and over again, there are intermittent results. So just to show these again, this is the ideal scenario with 2 of the same phone with little network activity. If you add network activity, the median discovery time raises, and if you use 2 different phones with network activity, it raises even more. So one thing that went really well during this project is that we successfully made a working library that people can use to handle Wi-Fi Direct. And based on our experiences, it's much easier to use our Wi-Fi, or use our library to implement Wi-Fi Direct than to use just the Android Wi-Fi Direct API. We feel that it's much easier because we created functions that people can call, and we handle a lot of the functionality behind the scenes. We also implemented a lot of unique features in our library that other libraries don't offer, and these include promptless connections, removing persistent groups, and we also log P2P events to the application so if someone using it can understand what's going on behind the scenes. All of us were new to Wi-Fi Direct and Android development, and we learned a lot throughout this process. As we mentioned in our midterm presentation, we created a Google group about Wi-Fi Direct to have any general discussions, share questions, share research. And this proved to be very useful because we received resources that we weren't able to find anywhere else online. And we also asked questions that were answered very quickly by some reputable developers. We invited a lot of people from Stack Overflow who have used Wi-Fi Direct, a lot of people from GitHub who have Wi-Fi Direct projects, and a few other prominent developers who have used it extensively.
So some things went poorly during this project, and one of the first things was that requirements changed pretty frequently for us, and that happened as often as on a weekly basis, which made it really challenging to do any sort of long-term planning, because something we were working on in 1 week might not necessarily be relevant in a few weeks. And so part of that was that this was a lot of research going into this project, so we weren't actually sure what was possible with Wi-Fi Direct at the start. And then another problem was that our development process, we didn't stick to very well, so we weren't very disciplined in our approach. We had originally planned on doing 2-week iterations with a release every 2 weeks, but over time, our team and our sponsor had to focus on having weekly demonstrations of progress, which quickly turned into having weekly releases of software. And so what this meant is we, in general, had lots of weeks where it was crunch time and we're trying to get some sort of demo out the door, but at the same time we were building up technical debt by trying to fix the release from the previous week. So if we had taken our time and stuck to the longer release schedule, it might have actually sped us up on this project. We also faced just continuous problems with Wi-Fi Direct. So I guess a simple way of putting it would be that we never really overcame the learning curve there. So every time that we had to develop a new feature or fix a bug, it was uncharted territory for us, which really slowed us down, and it made it so it was difficult to estimate how long anything would take us. And then going along that route, we also had a lot of unanswered questions. We mentioned earlier that we were keeping track of problems we encountered and the solutions to them. We have more problems than we have solutions. That's not for lack of trying. There's still bugs within Wi-Fi Direct and just problems that we weren't able to find solutions for.
There were a couple of features that we really wanted to get to that we weren't actually able to. One big one was a successful run of automated connection test. This might sound simple to be able to just connect to a phone, disconnect, reconnect, but there was a lot of interaction happening between those phones, and it was kind of a learn-as-you-go thing. And due to time constraints, we just weren't able to fully resolve that complexity and get a continuously running automated connection test app. The other one was comprehensive analysis of the collected data. The testing app took us till pretty much the end of the project, so we weren't able to do a lot of the comprehensive analysis that we had hoped we were going to be able to get to once we got the data.
As Brett mentioned, one of the biggest trade-offs we faced was focusing on the difficult technology versus building collision algorithms. In the beginning, we quickly decided that we wanted to focus on Wi-Fi Direct and determine if it's even suitable for crash avoidance, and we feel like that was a good decision. Another trade-off we faced was having fast iterations versus building robust code. Having the weekly releases was nice to have frequent visibility of progress, but it also prevented us from spending a lot of time planning and testing during those iterations. And as Brett mentioned, we spent a lot of time refactoring previous releases while we were still implementing new features. And there were also several Wi-Fi Direct roadblocks and challenges throughout this project. It was often hard to tell if an issue was because of our code or if it was because of an issue with Wi-Fi Direct. So from here on, our sponsor will use our library to continue crash avoidance, and our testing app can be used to continue analyzing Wi-Fi Direct and determine where more of the problem areas occur. We designed this so that more tests could be written fairly easily, so our connection tests could be enhanced and tested more. We also plan on discussing our test results and issues encountered online. We'll post a post in our Google group about that. And we also plan on promoting our library and encouraging developers to use Wi-Fi Direct more. Are there any questions? Yes?
Do you have any outside parties using your library at the moment?
Oh, we don't. We didn't spend much time promoting it until it was at a stable release version.
Yeah, we were consistently adding to it, so it was like our official releases happen really close to the end of the project, so that's why we kind of want to put some stuff in the Google groups and things like that about it, just to continue to promote it.
So you mentioned that you're trying to promote it. Do you intend to encourage people to actively develop on it? Are you gonna make that available for other people to contribute, or?
Yeah, it's available publicly on GitHub right now. I guess as they say, pull request log on.
Yep, that's actually a link to our
Yep, this is our
organization.
This is our organization where we have several repos using the library. Any other questions?
So, based on the results, especially with different phones, what's your recommendation for using Wi-Fi direct for collision avoidance?
So we still feel like it would take too long in most scenarios to connect and determine if you would collide. So we feel like there would need to be improvements from Android and possibly phone manufacturers.
You guys think of any cool potential applications for what you do have with Wi-Fi direct?
Well, so that demo we showed of sending a picture between it, we were joking that it was peer-to-peer Snapchat, essentially. But, I mean, you could also potentially stream video between phones. You could do anything that you could do over a network connection, except you don't have access to the internet.
And in conjunction to something like crash avoidance, it's been talked about using it as local backup camera or something even further to assist vehicle crashes, avoiding them.
It can pretty much do anything any other connection can do. It's just simplify it, make it easy to use, encourage people to use it, just making it more popular. So there's a lot of good opportunities there.
Any other questions? Thank you.
Ready? All right. Hi, everyone. We're Team Incredible, and we're excited to present to you today about our interval inventory management system and storefront. So to start off, our sponsor for this project was the organization Incredible, led by Linda Hafner, and our coach was Dr. Scott Hucker. I'm Alex Gerstenberger.
Richard Jester.
I'm Obi. Steven. And we're Team Incredible.
To give everyone a little bit of background, Interval is a nonprofit organization that located right here in Rochester that takes in surplus medical supplies from hospitals, clinics, stuff like that, and then ships it out all over the world to clinics and other organizations that need it at very little cost to those clients. The clients only have to pay a flat fee based on the container size that they're receiving. Not only does this mean that supplies are getting to the people that need them, it also reduces medical waste because these big hospitals throw out medical stuff all the time, just because, you know, they're a little on the old side, and they get new supplies every day. Oh. Interval's problem was that because all of their inventory is received through donations, each one of the boxes that they create is unique from every other box. So each item in their inventory is completely unique, and so they found that off-the-shelf tools were a poor fit for their item management. Also, in order for clients to create an order through Interval before the start of the project, they had to call up and, you know, working with Linda, figure out exactly what it was that they wanted, and, you know, there was no way online in order for them to create an order. So to solve that,
So to solve that, we basically integrated an inventory management tool to online storefront. Since Incredible comes every time with a unique set of supplies, so if they have 100 gloves today, tomorrow they might be able to have 10. And some things comes in packs that they don't just have everything assembled like you get it from the manufacturer. So they have to actually put notes in this and say, okay, we have this, but we don't have this that comes with it. So do you want that item or not? So this led to, like what Rick said, like they couldn't just pick up on off the shelf system to work for them. They actually needed something unique, and that's where we came in. And the features that we added was like the supply and inventory management. Inventory basically we'll see this in the demo where like an admin can add supplies that comes in and add them into the inventory and add whatever was it that was accepted. So if we got like 200 workers, we can add that to it. If we had like some beds and some furnitures, we can add that to it. If we had like syringes, depending on the quantity, so that way we can actually know what we have in stock. And clients can now similarly browse those inventories online and say, okay, this is what we want, and they can go through with a list system to see what's available. And we also have a system where you can track your history and see what you've got in the past and review it and say, okay, hey, I want this same order again, or I want to modify it a little bit, and this is what we want this time. Continue with the features. There's like I said, we have real-time inventory by status, and one important thing was the tier-based evaluation system that was integrated into it, because we know some high-quality item comes in all the time, so we don't want someone just going. Incredible didn't want someone just going in there to like say, okay, I want all the high-quality stuff. So now they have a tier system where basically say you can get one of this, 3 of this set tier system, and you can get like as much as you want on this tier-based system. So that way we can control quality of what is going to a particular industry. We don't want all the high-quality product going to one particular person.
Right. And this is our architecture. We've kept it pretty much the same since the last time we showed it. What was it, like in May now? So it's an MVC application. It's 3 layers. Right now we're using an Azure database as a data layer. The APIs are connecting between that and the view. And the controllers are divided into two types mostly. Ones are just kind of direct traffic between the views, so like just routing between the different pages and sending data between them, and endpoints for some of the actions that we have. So if you were like looking for boxes by category or all the OSF aligned to a client, it would send all that data back to it based on the information it got from the view. So the status of the project as we have it now is that we've had 24 user stories completed. 6 user stories are still in development, but we believe we'll be able to finish them by the end of the project. And 3 haven't been left implemented at all. And for those, at least one of them was like a spell checker for the fields that we've been entering. So if you were like entering description, you spelled something wrong, it would help you kind of like spell it. But we believe for things like that, there were workarounds such as third-party APIs, or we could just include them in another part of the include things in another part of the website that would kind of help them out. For the things that we still have in development, let's see, we kind of had to push into the back once we kind of had to develop the core functionality or put precedence on the core functionality. So for those, at least the dashboard page and the configuration page are kind of built or similar to things that we've already done before. So I believe that we're confident in getting those pushed out. The website right now is live, and Interval is able to go out and test on it. The loading time is a bit slower than we liked, but once it gets going, they can run their tests successfully, and there's not really any noticeable slowness. The decision to use Azure isn't really final though, since we want to also try and remove the initial load time. So I've been looking into AWS to try and figure out if that will also solve it. So it's not exactly finalized right now. The PayPal integration is complete. We were able to send invoices to Interval's account and able to get the confirmation that they actually went through. And they didn't accidentally charge 99 cents for a $2,000 container. That's all fine. So, still a few remaining features to be implemented, but we believe that we can handle it. And the requested documentation, since we want to make sure that they can use our product afterwards, so we've been developing a user guide and just like a developer guide to know how to operate certain features and how to change them. So a certain set of configurations, like how many items can you take from the depending on the tier, and where should you change that in order to make it work. Some stuff like that we try to include into the guide and make sure that they know how to change it in the event they hand it off to someone else and need to manipulate it. We still need to work on that since they are still testing with it, and they are getting back with us on their feedback. But we believe at least the admin section is pretty solid.
Alright, so real quick, I'm just going to run through our technology stack. So we've been using GitHub's, Trello, and Slack as collaboration tools of various flavors. We were previously hosted on GoDaddy and just very recently changed it to Azure and forgot to update this. And then we're using Visual Studio for development, and Kendo UI as a graphics library, and the .NET framework on top of a SQL server. So without further ado, let's jump into our demo. So, that's okay. So here's the home page of our app. It's very plain and simple. So the very first thing you're going to want to do is register. I've gone ahead and pre-filled out a registration form here. So you'll see that there's a fair amount of information, not just about your account, but also shipping information, some medical center information, and some stuff about your particular organization and your financial status. So register. So now we can't just log in right off the bat because all of our clients need to be vetted before they can access the system. This is to prevent people from spamming Interval with annoying requests, because once they're in the system, they can't just request orders at will. So you'll see that I am denied. So I'm going to go ahead here and log in as an admin. So here is the admin view of the app. So to start off with, because we've had a new account registered, we can go to the account review screen and see here that someone has registered. I'm going to review their account, which shows me all of the information that they've submitted during the registration. I'm going to approve it, and I'll now be able to log in. While we're here, I'm going to show you the core functionality of the app, which is inventory management. So there are two different types of inventory managed at Interval. There are supplies and there are equipment. Here you can see the supplies screen. Supplies are smaller items that are donated to Interval and then repacked up into boxes of similar contents. So that's what you see here, is a list of a bunch of boxes, in this case for the mother and child category. And all of these have can be ordered by the clients. The expiration dates are currently null because we just need to change the way that we're importing those from Interval's existing database. But so we can, just as an example, set one of those for about a year from now, save it. We also have the ability to search this view, and this is a search that will search all categories, not just the one currently being shown. The other type of inventory is equipment inventory. Equipment are larger than supplies. They are not necessarily repacked into a box. So for example, an entire x-ray machine. That would be something quite rare to come through, but it could happen. So we have the ability to upload images for equipment. So if I can go in and change this, if I would like to, and these images can then be shown to clients. You do need to refresh the page. We also have the ability to add new boxes, so I'll go through and do that right now. Just as an example. Save that. So now I'm going to take you back to the client view with that account that I created earlier, and we're going to place an order through Interval. So you can see we again have the ability to browse the two types of inventory. So here are all of the options for us to add to our cart. You'll notice that the fields shown here are significantly reduced from the other view. That's because a lot of those fields are really just for administrator use, and we don't need to show all of that information to the clients. So I can go through here and select some boxes of stuff to add, maybe from another category. And maybe I want to order the x-ray machine too. So now I can go to my shopping cart, and here we can see a unified, just quick list of everything that we've added to our cart so far. We can continue with the checkout process, which will take us to a confirmation screen. Here we're asked for our payment option. So we do have PayPal integration. At the moment, we don't have a sandbox API key set up. We have a live API key, so rather than create real invoices for fake orders, I'm going to select other payment method. What this will do is this will mark the order as unpaid in the database, which we can see here under our client order history. Now if we were to log out and log back in as an admin, we'll be able to see that an order was placed. And within that order, we'll be able to modify some of the fields. So let's say that our client contacted us after they submitted their order and said, "Oh, we're going to pay by check and we're going to mail it." We eventually get the check, so we're paid and we can mark that. But maybe in the meantime, we've discovered that we actually don't have one of those boxes that they originally ordered. So the admin does have the ability to go back in and edit orders. So maybe this box is no longer available, but in exchange, we'll give them a different one instead. And we can also add equipment. So then perhaps you might eventually ship your order, so you can mark it as shipped, all of which will then be shown to the client as well. And the final piece of functionality here that the admin has that's important is the ability to download a packing slip for the order. This automatically generates a PDF that contains all the contents and some other information about the order, which can then just be printed and included with the physical order when it goes out. I don't think is that everything? Oh, whoops. And so I'll take you back to our presentation. So, in reflection, we had a pretty rocky road on this project, particularly through kind of the middle stretch, around when between the interim presentation and the next month or so after that, we didn't really get a lot done. Yes, there was a break in there, but even so, we wonder if Scrum may have been a mistake. We feel like due to a lack of plan early on. We spent a lot of time thrashing. Related to that, we spent a lot of time focusing on tools and configuration management. Wasted over 100 hours on various deployment issues, easily trying to get various servers working. We first tried an RIT hosted VM with no luck. We tried GoDaddy with some but minimal luck, and finally are now currently hosted on Azure, which may or may not be the app's final resting place. And so our cohesion and coordination were rocky at times. There wasn't clear communication about what the status of work was, or how we were going to get everything integrated, so that sometimes led to mad dashes prior to delivery dates trying to get everything integrated and merged. However, we have had a strong final push the last week or two, and have delivered a lot in that time, and we have a few features left to go, but I think that it's definitely feasible for us to finish everything off. So our next steps, implement those features, finalize our choice of deployment, and get that set up, do our final handoff to Interval of documentation and all of the keys to the kingdom, and afterwards, maybe try to provide some ongoing support. Answer some emails, give them a hand if they ever run into trouble. And that is all. Does anyone have any questions?
What were some of the features that were unavailable in the third-party tools that you guys were able to provide with?
Well, so the biggest one just being that the classic paradigm of an inventory is that you have items that have quantities that go up and down, and if you run out of an item because someone buys you out of it, usually you can just order more, and then you have it in stock again. But like Obi and Rick were saying, each box that comes through Interval is entirely unique. They get in a bunch of medical supplies, not packaged up, just in bins, and volunteers come in and sort them and place similar stuff into a box, and at the end the box is labeled with what's in it. But the contents of that particular box, there might never be a box with those contents ever again. So each box is kind of its own discrete entity, and that's what's unique about this particular inventory tool.
So it's easier to add those new types of items, whereas a lot of other ones, you have to kind of define items and then the quantities based off that. Is that kind of?
Right, and then if you're using a tool that employs the classic quantity paradigm, then you ultimately end up with a whole bunch of items with quantity 0, just like sitting in your inventory from like a long time ago and stuff like that. So.
Did you work with any users to see if they like the usability of the app and if it would be useful for them?
So we've been working with Linda. She is the primary user from the administrative perspective. We have not actually worked with any users on the client side. Any other?
Did you mention, I think towards the beginning about actually tracking the containers? Is that something that you look into doing, is figuring out like an optimum way to track shipping containers?
So that's something that we discussed. Ultimately, the conclusion was that isn't really necessary. The standardized box sizes that Interval packs in means that a fixed number of boxes fit on a pallet, and then a fixed number of pallets fit in a container. And beyond that, we thought it was reasonable to leave up to the discretion of whoever's managing the warehouse, to pack the heavier stuff on the bottom and the lighter stuff on top, and we're not going to try and, hand them a 3D grid of where they're supposed to put every single box on every pallet. There's definitely some optimization possibility there, but, just given the scope and the amount of time that we had, we didn't really feel that it was necessary.
I know you guys mentioned that there were some issues with initial load times. Were you able to kind of pinpoint that? Was it like a scalability of many users trying to use it, or just too much data being stored on a server that wasn't built to handle it?
Yeah, it's it's just that Interval as a nonprofit has a tight budget, and so we were trying to not use, fancy instances on Azure or anything. So we're opting for pretty economy plans. And our app isn't particularly heavyweight, but it is built on .NET, so it's also not a lightweight either. And so really what it is on some of the servers that are shared resources, there's just a long, like your first request to the page, if the website hasn't been requested at all within an hour, the server will have essentially deallocated all your resources, so it can take 30 seconds to a minute for it to wake up. After that, it's responsive in half a second, or faster even, standard. Thank you.
Thank you.